In a pure semiconductor, the number of conduction electron is 6 into 10 to the power 19 per cubic meter. How many holes are there in a sample of size 1 centimeter into 1 centimeter into 1 millimeter? That is the question. So, how we are going to solve it? That is a, just you think it, in case of the pure semiconductor, in a pure semiconductor, number of electrons is equal to number of holes. So, and here the it is given that there are 6 into 10 to the power 19 electrons are there per cubic meter. So, the volume is given 1 centimeter, means 1 into 10 to the power minus 2 meter into 1 into 10 to the power minus 2 meter into 1 millimeter. That is the dimension is given 1 into 10 to the power minus 3 meter. That means your 10 to the power 2 to 4 and 10 to the minus 7 meter cube, right. So therefore, number of free electrons will be, how much is the number of free electrons? The in 1 meter cube there are 6.6 into 10 to the power 19 conduction electrons are there. So, 6 into 10 to the power 19 number of free electrons in 1 cubic meter. So, that much cubic meter is there into 10 to the power minus 7. So, that comes out to be 6 into 10 to the power 12. That will be the number of free electrons. अब इतना free electrons है तो so therefore number of holes कितना होगा? Same 6 into 10 to the power 12. इतना holes भी होगा, right? That is in pure semiconductor number of free electrons is equal to number of your holes. So, volume is given and number of free electrons is this much and number of holes is this much. Another question, indium antimonide has a band gap of 0.23 electron volt between valence and conduction band. Find the temperature at which KT, Boltzmann constant into absolute temperature, equals to the band gap. So, here energy, how it is going to be solved, energy दिया हुआ है 0.23 electron volt, right, and the value of K is also Boltzmann constant, also we know 1.38 into 10 to the power minus 23 इतना लगभग होता है. So, energy should be equal to K into T. We have to find the temperature. T is equal to E by K. Put the value E 0.23 in joule, we have to multiply by electronic charge 1.6 into 10 to the power minus 19 by K. The value of K is 1.38 into 10 to the power minus 23. If you are going to calculate, I am using the calculator, that comes out to be 2670 Kelvin approximately. That is your temperature. This E this much by K. So, that comes out to be 2670 Kelvin. That should be your answer. Other question is the drift current in a PN junction is 20 microampere. Estimate the number of electron crossing a cross section per second in the depletion layer. So, how we are going to solve it? drift current is given 20 microampere. That means definitely when the microampere is there, that means it is in the reverse biasing, in the microampere order, reverse biasing. And here both holes and electron both are moving in case of semiconductor, p-n junction diode. These holes and electrons are moving, both are the charge carrier. So we can write the current, we know current is equal to number of electrons into electronic charge. Here the electronic charge, here the charge carrier is both electron and the holes, and both are equal, so we can write it, and holes are also having the same charge as the electron is having, so twice E into N. So therefore number of charge carrier will be I by twice E. I is given 20 into micro 10 to the power minus 6 by twice E, 1.6 into 10 to the power minus 19. So that comes out to be, if you are going to calculate, I am using calculator as I told you, 6.25 into 10 to the power 13. That should be your answer. 6.25 into 10 to the power 13. That should be your answer.